Hi, my name's Ian Griffiths. I'm a Microsoft MVP and Technical Fellow at a UK consultancy called Engine. We are Microsoft Gold partners for Cloud Platform, Data Analytics, Data Platform, DevOps and Power BI. In this talk, I'll be explaining how to navigate the bewildering array of data services offered by Microsoft Azure. Azure is a modern cloud platform, and as such it has to serve a wide range of different use cases, and so it offers a lot of different data services. But the effect of this can make it rather hard to work out where to start if you're not already very familiar with the offerings. So suppose I'm here in the Azure portal and I decide I want to add something to manage my data. Well, I go to the storage section in the marketplace and say, well, show me everything you got. And there's really quite a lot here. And in fact, even if we narrow it down just to the services offered by Microsoft, well, this little load more button appears down the bottom and it just keeps coming and coming and coming. And you can keep clicking on this and it will just get a longer and longer list of services that broadly fall under the storage section of the Azure portal. So how are you supposed to work out what to use when there's so many different options available to you? Well, that's what I'm going to try and help you with in this talk. So the approach I'm proposing for making this tractable is to split things up into the kinds of service and then to look at those in a bit more detail. So the offerings that Azure has in the data space do broadly fall into a number of reasonably distinct categories. So for example, there are services for dealing with file-like things. Now that varies in its exact nature because there are services offering file shares that you can attach to. There are offerings representing disks for virtual machines. There are things for storing just blobs of data accessible over web APIs. But broadly speaking, they are all unified by the fact that you're storing things that are file-like in one sense or another, in that they are just linear streams of bytes. So we'll look at those. Then we'll look at the slightly more structured data stores. So perhaps the obvious candidate for that would be SQL Server, or Azure SQL as it is in its Azure incarnation. And there are other relational data stores also offered as part of the set of built-in platform as a service features in Azure. And there are some other structured stores that are not relational. There are also table stores, there are key value stores, there are document stores. But all of these are kind of database-like to a greater or lesser extent. They're not storing files, they are storing data according to some particular data model or scheme. We're also going to look at messaging, which might not seem obviously like a storage concern, but there are a couple of reasons for looking at this. One is that one of the main messaging options in Azure is actually part of the broader service known as Azure Storage. So when you create an Azure Storage account, you get blob storage, file storage, table storage, and messaging. So we're going to look at it because it's part of one of the services we have to look at anyway. But also, one of the messaging options, actually a couple of them, do hold data persistently. And so they can sometimes form part of a data store system for certain kinds of applications. So they're definitely relevant to this talk as a whole. Then there are options for data processing. Now, to some extent, there's overlap here with the databases. So SQL Server obviously is able to perform queries against the data that it stores. So you've got a single service that combines storage and querying. However, there are some services which essentially offer querying as a feature on top of something else. For example, there's something called SQL On Demand, where you can run SQL queries, T-SQL queries, on top of data stored in, for example, CSV files or JSON files or Parquet files just stored as files in blob storage. So we'll take a look at that. And there are analytics platforms. So there's Azure Synapse Analytics. There's also Databricks, so things based around Spark that are able to go and perform large-scale analytical operations against data stored in things like Data Lake. So we'll look at those, and there's related features. There are things like the Azure Data Factory for ETL operations and other things for generally wrangling and mangling data. So we'll look at that as well. And there are tools for interactive analysis. So there are features in several of Microsoft's data storage products that let you run a notebook. So you can get a Jupyter Notebook style experience in a few of their products, actually. So we'll look at those. And there are also some more specialized analytics features as well. So there's the Data Explorer, there's Power BI, there's Azure Time Series Analytics. So we shall be looking at the various things available in that category as well. So most of what we have to look at falls into one of these groups, and this makes it slightly easier to find your way through the set of offerings, because if you're looking for a thing that's going to store data in a sort of linear sequence of bytes, you know you don't necessarily need to look at all the things to deal with messaging or analysis or so on. So hopefully this approach will make it easier for you to understand what Azure does have to offer and how you can narrow down your search to see which of its offerings might be appropriate to the applications that you want to write. So we're going to start by looking at services based around files and file-like things. So the obvious service to look at would be Azure Storage Files. So Azure Storage is a suite of services. You can create a storage account in Azure and you get a suite of services that includes Azure Storage Files. And this gives you the ability to present a file share. So you can connect to this with anything that understands the SMB protocol. So this provides persistent storage. It can be potentially backed up across multiple regions geographically to provide disaster resilience. And this is actually used as the basis for some of Azure's other offerings, incidentally. So there are certain services in Azure that build on top of Azure Storage Files. So this is a way of doing file shares. There's also Azure NetApp Files, which is a kind of more enterprise and application specific set of services. So they provide support for things like very specialized workloads. So they provide file services dedicated to supporting things like Oracle databases or SQL Server databases or high performance computing environments where they've set the file share service up to be particularly adapted to certain kinds of workloads. So that's a more sort of high-end and advanced offering, but if you don't necessarily need the specific performance characteristics, then Azure Storage Files is probably good enough. And then there's Azure Blob Storage. So when you create an Azure Storage account, I'll show you what this looks like in just a minute. An Azure Storage account gives you both files as a service, and that presents as a file share, but it also provides a blob store. And blob stands for binary large object, as I expect you know. It's basically a big file or even a small file, a stream of bytes stored somewhere. And really the primary distinction between blob storage and Azure File Storage is that blob storage does not present as a file system. It's not something you can mount as a drive in an operating system that understands SMB. It doesn't offer an SMB or an NFS endpoint. It is specifically HTTP based. It has a REST API. There's a client library available for most popular languages that you can use to access the thing. So it is a bit more specialized. You have to generally write something to use it if you want to store data in there. Although because it has an HTTP API, fetching data out of it is just a matter of executing a web request. Any browser can pull data out of blob storage, and actually that's a moderately popular use of it. It does get used as a means of just providing static content on the web, but it's also a service in its own right. And so this is in some ways sort of the fundamental storage mechanism in Azure, because a lot of things actually build on top of this. So there are specialized kinds of blobs that act as the disks for virtual machines in Azure. Now, the kinds of blobs that do this are set up differently. You create what's called a page blob as opposed to a block blob, and a page blob has certain characteristics that are optimized for use as the underlying disk drive of an operating system, of a VM, and that make it slightly less convenient as general purpose storage. But it enables them to offer certain services like very high-speed copy-on-write behavior if you want to duplicate the disk. Also, you can have a VM disk that is backed by SSD storage, so solid-state storage for higher performance. So we'll look at some of this in a bit more detail when I show you what the storage account looks like. And also, Azure Blob Storage has archive facilities. You have the option when you create a storage account and when you add blobs to it to indicate that some of the data going in there is intended for archive purposes. And this has an impact on performance and billing. It means it's much cheaper to hold the data there for a long time, but actually retrieving it gets more expensive and slower. So if you're planning to store something for archive and you hardly ever intend to touch it, then you can tell Azure this and it will store it away in places that are slightly harder for it to get to, but which don't require as many live resources to guarantee the availability. So there's a trade-off to be made there in terms of how the backend implements that, and there's a corresponding trade-off in what you pay for it. So that's another thing that blob storage gives you. So blob storage is kind of the general purpose workhorse for a lot of file-like things. And actually it's behind the last thing on this list, which is Azure Data Lake Store. So data lakes are these blob stores that are used often by systems like Spark and Hadoop, where you have large quantities of data dumped into what is essentially logically a file system, but it's one that is designed to be accessed by heavily parallelized systems such as Apache Spark that are going to be able to run queries over potentially terabytes, large amounts of data in bulk. And so Data Lake Store is designed for that, but actually it's really just kind of an option you switch on blob storage, and it just turns on certain extra features that are relevant to that world. So again, blob storage in a storage account underpins a lot of this. So given how much blob storage in particular and Azure storage accounts in general underpin things, let's take a look at what they actually show up as in the Azure portal. So I'm in the Azure portal here. And as with just before, I'm going to go here and click on the Create a Resource button. And actually storage accounts show up here for me. Now, the exact set of items in this list varies over time. So if it doesn't show up for you when you try it, you can just type in storage account here and it will show up. And that's the same thing. If we click on that, it gives you a brief overview of what it is you're going to get. Microsoft Azure provides scalable, durable cloud storage, backup, and recovery solutions. So let's click Create. It won't actually create it straight away. It'll give me a bunch of options. So there's the usual Azure stuff, which is what Azure subscription and resource group am I going to put this in. So let's create a new resource group for that. And you've got to pick a name. So these things are, by default, behind public-facing URLs. You can configure them not to respond to requests, but the default is that these things are visible. They have a domain name, and so this storage account determines the name. So if I just put my store or something, it will tell me I can't have that name because somebody has already created an account with that name, and because these end up forming DNS names, they've got to be unique. So let's pick something that I hope no one has done before. My initials, SQL bits 2020. Yep, that's not taken. Right, then you've got to say where you want the thing. So Azure has loads of different locations that they can create things in. And I'm actually going to put this in North Europe. Let's look at some of the options here. I'm going to zoom in a little bit just to make this more visible. So first question we're asked is what level of performance do we want? Do you want standard or premium? So standard storage accounts use conventional hard drives, but obviously so there are performance issues with that compared to solid state drives. So you can say you'd like a premium storage account instead, but this does actually change what you can do. Essentially, this is here for building hard disks behind Azure virtual machines. So if you turn that on, you get access to the solid state disk infrastructure, but you basically switch off more or less everything else. So I'm not going to do that now. I'm going to go with a standard account so I can show you the full range of things that are available. Next is going to ask me which kind of account. Well, unless you've got some very pressing backwards compatibility need, you basically want the latest one. And then you need to tell it what kind of redundancy do you want. So by default, you get locally redundant storage. What this means is they will store at least three copies of all your data, but it's all co-located. And so that means that you are essentially covered from any hardware failures. If anything fails in the data center, your data will continue to be available. However, if a meteorite crashes into the data center, then you've got a problem because it might have taken out all 3 disks at once. So there are other more expensive but more reliable options. So there's zone redundant storage, and this uses the Azure concept of zones, which are kind of linked regions that are close together. So they've got very high performance connectivity, but they are physically separated. So if you lose one region due to a natural disaster in a particular zone, then you're unlikely to lose the other one as well, because they're far enough apart to be able to back things up. So this gives you a level of disaster resilience that you don't get with a local one, but obviously you pay for it because they've now got to allocate more hardware and bandwidth to ensure that they can ship copies of your data between the different data centers that are going to supply this. The next one up is geo-redundant storage. So in this case, the data travels a lot further. So you can select a backup location which is not whatever the zone pair for your chosen region is, because with zone redundant storage, you don't get to say where the backup goes. But if you choose geo-redundant storage, then you get to say where you'd like the backup to be. The next step up from this is read access geo-redundant storage. Now the distinction here is that you can actually access the backup. So not only is Azure maintaining a complete backup of all of your data in some other geographic region, you are also able to read from it without having to fail over to it. So with geo-redundant storage, they maintain a backup, but the backup is essentially inaccessible unless you end up failing over to it. So you have access to whichever system is the online one at the time, but you can't kind of use the backup. With read access geo-redundant, you can use the backup, and this might be interesting for scenarios where you want to have a master copy of the data that is available for update, but then to be able to access that data from other places in the world with lower latency. So this might be a thing you would turn on not just for redundancy purposes, but also to change performance characteristics. And then finally, we've got geo-zone redundant versions of those. So this combines the geo-redundancy, so multiple different locations, with zone redundancy within those locations. So that's the kind of belt and braces, most secure approach. Now for this demo, I don't need anything more than local redundancy, so I'm going to leave it at that. The next question you're going to be asked is, which access tier for the blobs should it presume by default? What's this about? Well, remember earlier I mentioned that archiving is a feature of blob storage. You can tell Azure that certain blobs are ones that you're putting into storage for long-term archive and that you don't expect to need to retrieve anytime soon. So Azure makes a distinction between hot and cool storage here. Now you can specify when you put the blobs in there, the APIs for the blob storage do let you specify which access tier you wish to use as and when you create the blob. However, this is a newish feature. This wasn't here in earlier versions of Azure Storage, and so a lot of client code doesn't say which type of storage it actually wants to use. And so you can just say here which Azure should presume is the correct default if the client doesn't specify. And just to remind you, the distinction is with hot, Azure will do work to make sure this is available quickly, and so the price of accessing the data is relatively low because it's kind of baked into the price of storage. So you pay a certain amount with Azure Storage simply to hold the data, and you also pay for transactions that access that data. And the trade-off here is that if you have hot, your per gigabyte storage costs are higher than they would be for cool, but your transaction costs are lower. Whereas if you select cool, the long-running storage costs go down. The cost you pay per gigabyte is significantly lower. However, if you actually ask to see the data, then you pay more because you told Azure, I'm not going to be using this very much. So it ends up putting it in places where it has to do more work to make it available to you. For the purposes of this demo, I'm not doing any long-term archiving because I'll be deleting this account when I'm done. So I'm going to stick with the hot approach. So there's some other things you can set up here. So remember I said that by default the thing's available on a public endpoint. However, you can change that. You can keep the public endpoint, but you can limit it to certain private networks within Azure. So it still looks like a public endpoint to the code, but the firewall will be set up in such a way that only certain networks will have access to it. Or you can configure a fully private endpoint, so that way the thing will live on a virtual network that you've configured in Azure. You'll need to create the network for that to happen.
And that way you can make sure that only the services you've explicitly granted access will have access to it. So, moving on to data protection. There's also soft deletion. This is basically saying that when you ask to delete something, you can ask for Azure to mark it as having been deleted without actually removing the data. And this can be important in certain regulatory frameworks. It might be that for legal reasons you actually aren't allowed to delete data, but it might be convenient to make it look like data has gone from an API perspective. You'll still be able to get hold of it by going through the APIs with options that say, I need to see the things that are allegedly deleted. You can also enable this soft deletion for the file services. So this is not just blob storage. I'm creating a storage account, and that will give me a suite of things: blob storage, table storage, file shares, and messaging, queue-based messaging. So you can also enable the soft deletion there. There's also versioning. It is possible to track versions of blobs. This is a more explicitly managed thing. You can ask it to do a checkpoint in time for certain blobs, and that's a feature that you can turn on or off, because obviously it has to do work to make that happen. There's also the notion of a change feed. It is possible to get blob storage to report the sequence of changes that led up to the blob's current state, but we're not going to use that in this demo. Also, you can say whether you're going to allow non-TLS based access to the endpoint. By default, your blob store will only be accessible to clients using HTTPS. However, there are some situations in which you are deliberately placing fully publicly accessible information on your store because maybe you're using it as the static content store for a website, in which case you might want to say, well, actually, I don't want to force people to use HTTPS, and you can turn on public blob access to do this. So public blob access is the ability to configure certain parts of the store to allow unauthenticated communication if you want it. So I'm going to say I'm going to enable secure transfer, but I'm not going to allow anyone to access anything in here without providing some sort of auth. By the way, this doesn't completely open the door. What this does is it makes it possible to open the door. So if you set this to enabled, you've then got to unlock individual sections of your storage in addition to the storage account. You can configure the version of TLS that's required. It defaults to 1.2, but if for some reason you've got clients stuck on older versions, then you can wind that down. There's some ability to do very, very big files, although there are some constraints on that. And also, there is this data lake storage feature. Data lakes, as I mentioned earlier, are typically used in systems like Hadoop and Spark. They are essentially file shares, but they're file shares designed to be used from heavily parallelized data processing systems. And it used to be that Microsoft had a separate data lake store product, but then with Azure Storage version 2, they actually wound the data lake storage functionality into blob storage because they're not really very different as services go. They overlap so much that it made more sense to make this a feature. The main things it does is that this enables the ability for directories to exist in your blob store even when they've got nothing in them. Because when blob storage was originally created, it didn't really have directories. It was really just one massive, great big flat list of files. And there were conventions for if you wanted to pretend you had directories, you simply put slashes in the path name, and lots of tooling will make it look like you've got a folder layout. However, for that to work, there's got to be at least one file in every single directory before you can see it. Whereas if you enable the hierarchical namespace, one of the things you get is the ability to have a directory that is present but empty. Another thing it gives you is the ability to apply different access control rules on individual directories within the storage account. So without this turned on, blob storage is essentially a big flat list of files, and the only level of granularity you have is a thing called a container. You can create as many containers as you like of files, and they can have their own security settings, but within a container it's just one sort of amorphous mass unless you've turned on the data lake storage features. This has some other impacts though. This changes the pricing. This actually changes the per transaction cost, and one of the reasons for that is that if you turn this on, they assume you are going to use it with things like Apache Spark, and so you get a slightly different supported performance profile, and you end up paying for that. Also, you need to switch this on for the store to show up in certain other bits of Azure. So if you use, for example, Azure Synapse Analytics and you ask it to connect to a data lake, it's only going to show you the storage accounts where you've enabled this feature. So if you want to be able to treat a blob store as a data lake, you have to turn this on. Now, for this demo, I'm going to leave it switched off because I'm not going to be using those features, but that's what that's all about. And now we're on to the general Azure stuff. You can add tags to any resource in Azure, so that's just a standard thing. And now we are ready to go. So it's just going to show me a summary. It's going to make sure I haven't chosen any nonsensical combinations of things. So I can just read through this and say, yep, those are the options I selected. And then I'm going to click Create, and it will then start to create the thing for me. So I'm just going to fast forward the video while it does this. And there it is. We're done. So I'm just going to go to actually the resource group rather than the resource itself because I want to pin this whole resource group to my dashboard. So now when I come here, I can see this resource group and there's my storage account. So let's take a look inside it. What did we actually get? So it's showing me here on the overview page the services that the storage account offers. We've got containers. These are blobs. So the blobs go in your containers. There's a file share system. There's tabular storage. We'll come back and look at that in a bit. And there's queue-based storage, which we'll also look in a bit. So for now, file shares and containers are the main interesting bit. So file shares let me set up SMB file shares, so you can then connect to that with any operating system that knows how to speak SMB. Bits of Azure infrastructure use this as well, so you can use these things from things like Azure Functions as well. But I'm going to look in containers. So this is the blob storage facility. And the structure here is that you can have any number of containers, and a container has a name. I'm going to call this SQL Bits Demo. And if I had enabled the account level public access feature, I would be able to specify whether this particular container is publicly accessible. But because I turned that off at the account level, I'm now not allowed to specify. And we can also specify what the encryption requirement is. So in this case, it's going to default to the account level encryption at rest. So let's create that. And now I've got a place I can put my files. So I can upload files from here. They give you a user interface dropping things in. Or you could use the Azure Storage Explorer, which is a free Electron-based app you can download from Microsoft. And basically, you can just put blobs in here. So if I were to go in here and select a file, let's go into videos and let's just pick one of the test videos I did earlier. So I'm going to upload that video into here. That's a 5 meg file, shouldn't take too long. And you can see the thing, it's given me a green tick, that's done. If I close that and close that, you can see here is my blob. Its access tier is hot because that was the default that I specified. And if I click on this, it will show me the details. There is a URL. So that is the identifier for it. And you can see my account name that I chose earlier appears in the URL. That's why the storage account name has to be unique, because it's going to appear as part of the URLs generator for blobs. And it's showing me information about this. It remembers when it was created, shows me how big it is. It knows what the content type is. So actually, I think the web browser correctly set the type that based on the video encoding in use. There's an MD5 hash that can be used for things like ETAG-based work. I'm going to quickly talk about SAS, Shared Access Signature Keys. So this is a way of making individual blobs or individual subsets of blobs, like a container, available without having to grant the keys to the kingdom to your client. What you can do is build a URI that has basically a special thing in the URL. Let me show you what it looks like. It's this signature here. This is a generated signature that basically anyone who sticks this on the end of the URL, so you can see here is a blob URL with this thing on the end of it. If you use that, then you can download this blob without having to authenticate the connection. So you'll use HTTPS because I made that mandatory, but you can download the blob as long as you've got this. These things time out, so this thing expires on the 5th of September at 14:35 UTC. So by the time you're watching this, this is no longer going to work. So actually you won't be able to download this. So these are time limited tokens you can stick on the end of the URL. And the purpose of this is to make it possible to hand out URLs people can use to access things in blob storage without necessarily having to give them complete control over the account. Because one of the things about blob storage is that if you don't enable the hierarchical data lake features, then you've got quite limited control over security. A few more things just to look at here. You can configure CORS on this. If you want to make this accessible to JavaScript clients, you can enable that. You can change the default configuration settings. You can configure how it interacts with virtual networks inside your system. And it's also got a feature for running a static website out of the thing, although I'm not going to do that now. So that's storage accounts for you. So specifically, we looked at the blob store. I'll be looking at some of the other things in a bit more detail later on. But this is how you create a storage account, and this is what they do. They are fundamentally a store for blobs, and they pop up all over the place in Azure. So there are a few more file-oriented features in Azure to talk about. So there's backup. Microsoft offers backup services for various things in Azure, actually. There's backup for entire VMs, if you're using virtual machines, but they also offer backup services for file shares of the kind that we just looked at briefly in Azure Blob Storage. There's also a service for backing up on-premise file systems to the cloud. And also system state as well, so you can back up entire machines into Azure. And there's also more specialized things. There's a SAP HANA backup system as well. There's also some options for edge file storage. Now, what do I mean by this? So sometimes you might want to have the primary copy of your data live in the cloud, so you can use the redundancy that Azure offers, the geo-replication to provide multi-site resiliency, but the problem with that can be that it's then relatively slow and expensive to access. If you have a moderately large office with lots of people needing to access the files, then having them be in some data center somewhere hundreds of miles away from where people are actually working could be a problem. So one approach is to say, well, actually, I would like to have a local copy of the data. And there's a few modes for this. There's a few different variations on this theme available in Azure, depending on exactly what it is you want to do. So let's talk about those. So one option is to use something called Azure File Sync. So this is a feature you can enable on a Windows server that has what looks like a normal local file share where the server just holds copies of the files locally, but it synchronizes them with a copy up in Azure. So people are just working with a local server like they normally would, but anytime they change a file, that will get pushed up to Azure. And if someone on a different site changes the file and that change gets pushed to Azure, that will then be synchronized back down to the local copy in other offices if you've got multiple locations. So that's Azure File Sync. It's a Windows feature that works in conjunction with Azure. There's also something called DataBox, and this is actually a family of products. So one of the things you can do with DataBox is you can actually get Microsoft to send you literally a big box that you put all your data in. It's a kind of ruggedized hard disk device with huge amounts of storage on it, and you can copy all of your data onto that and then ship that back to Microsoft, and they will then copy it into the cloud. This is useful in scenarios where you want to migrate existing data to the cloud, but for one reason or another, you don't necessarily want to send all of that over the internet. Maybe you've got so many terabytes of data that it is simply going to be faster and more economic to put it in a van and drive it to where it's going. As the old saying goes, never underestimate the bandwidth of a transit van full of backup tapes. There's, the amount of data you can ship by actually physically moving storage devices around is massive. So even with the fastest internet connections in the world, that might actually be a better option. But there might also be security concerns. It might be that you just simply don't want all that data flowing over networks where you don't necessarily have control over them. And so physically shipping the data might actually be a preferable option. There's also Azure Data Share. This is really a service for sharing large volumes of data for collaboration purposes. There's also a thing called Azure IoT Edge and Azure Stack Edge. Now, both of these are a slightly different sort of theme. These are for where you have devices that are going to need to have access to data storage. So Azure IoT, short for Internet of Things, is a set of technologies Microsoft offers in Azure. And one of the things that they provide is software that can run in a small device, such as a Raspberry Pi, like a small mobile ARM-powered device. And it provides a local blob store that can synchronize with systems up in Azure, and also a local event hub that can also push data up to Azure, even when you've got limited connectivity. Azure Stack Edge is a slightly different proposition. It's a sort of similar kind of idea, but Azure Stack has more specific hardware configurations, but it's a similar sort of notion. You might also have heard of Store Simple. This does some similar things to Databox, and actually quite a lot of what it does is being moved into other services because it is being end-of-lifed. And finally, I'm not going to talk about these in detail, but be aware that there are a couple of file-based offerings that are aimed at specific high-performance compute scenarios. So there's Azure FXT Edge Filer. This is an actual physical product. This is a thing you install in your office. And there's also a high-performance computing cache system, but they are for quite specialized workloads, and I don't have time to go into those today.
So much for files. But what about more structured forms of data storage? The obvious thing to look at now would be SQL, and there's several different ways of supporting SQL of one kind or another. There's Microsoft SQL Server in various forms, and we'll look at that in just a moment, but there are other options. Microsoft provides managed hosted instances of various popular relational databases, including MySQL and PostgreSQL. There's also their own Cosmos DB, which offers a SQL-based personality, although it's not relational. And it also offers various other modes of access as well. And we'll take a look at that later. But first of all, let's look at SQL Server. You'll be unsurprised to know that there are many, many different ways of supporting SQL Server on Microsoft Azure. So if you're coming from an on-premises background where you host your own SQL Server, then arguably the most natural progression, if you want to move that into the cloud, is to use SQL Server running inside a virtual machine. So this is the most direct translation of in-house infrastructure to the cloud, and this is a supported scenario and lots of people do it. However, there is also Azure SQL Database, and this is a platform as a service offering. So rather than renting a VM, installing Windows, keeping Windows up to date, installing SQL Server, keeping SQL Server up to date, with Azure SQL, you are buying a managed service where Microsoft maintains all of the hardware and operating system and updates for you and just provides you with an endpoint. And it speaks the same protocol as SQL Server, so all the same clients that can talk directly to an ordinary SQL Server can also talk to Azure SQL. Now, it's not identical, and actually earlier on in Azure's history, the features available in Azure SQL were really very limited compared to what full SQL Server can offer. But they've gradually narrowed that gap over time, and for a lot of applications, this actually makes sense as the right way to go, because the reductions in maintenance overhead by letting Microsoft look after the whole thing can be quite dramatic. However, it's not the only option. But if you do go down this path, you've got various ways of provisioning it. You can just buy a database and you pay for the level of capacity. So there's a pricing model based on what they call well, there's several different pricing models, but they vary. Some of them are based on the amount of work you ask the database to do. Some of them are based on pre-provision performance. But there's also a more complex notion of something called an elastic pool, where you can get Azure to adjust the amount of compute capacity available to you in response to your usage. But you can do this across multiple databases. So rather than having to have, if you've got, say, 20 databases, rather than having to have 20 different sets of provisioning, you can say, well, I just want one kind of wodge of capacity that will go up and down as I need it to, and each of my databases want to be able to use that as and when necessary. So this can be quite a good way of consolidating the price of the resources in Azure that you're using while maintaining multiple different databases. On the other hand, another way of going is Azure SQL Managed Instance. So this is a fully managed service like Azure SQL Database, but effectively it's a full privately run copy of
real SQL Server. So rather than being the slightly modified version that Azure SQL uses, here you are getting a full SQL Server, but unlike installing it on a VM, Microsoft's going to maintain the thing for you. So they'll maintain the operating system and the SQL Server instance. This is a slightly more expensive way of doing it than using Azure SQL, but you do get the full feature set. There are some other alternatives. So Azure Synapse offers a couple of ways of using SQL Server. This is the new brand under which SQL Server Data Warehouse has vanished, but there's a completely different SQL offering also provided by Azure Synapse called SQL On Demand. Now this is a very interesting approach. It's the same T-SQL engine, so the basic syntax is the same. The exact feature set won't be the same as a full SQL Server install, but the language is being executed by the same underlying engine. And with SQL On Demand, you can run SQL queries across data in a data lake. So if you've got loads of blobs containing JSON or CSV files or Parquet files, basically data spread across multiple files in a data lake, you can use SQL On Demand to execute queries over that data. And they call it on demand because you don't have to provision a server. You don't have to load the data out of the data lake and into SQL tables before you can start to use it. The query engine can operate directly against the data where it lies. Now there are costs to this, of course, because it can't do the same sort of indexing that SQL Server would normally do. You're working with the data in the form that you find it rather than in the more efficiently packed way that SQL would store it internally. But if you want to avoid a whole kind of data migration thing where you get things into the server before you can start to use them, then SQL On Demand is actually a very interesting technology. Also be aware that Azure Backup that I mentioned earlier has features specifically for SQL Server running on VMs. And there's also Azure SQL Edge, which is the ability to run a SQL database on a device rather than hosting it in the cloud, but in a way that is able to synchronize with an Azure database up in the cloud. And just for completeness, there are other SQL-based servers available. So Microsoft provides hosted offerings where you just don't have to create a VM. You just say, I would like an instance of, for example, MySQL or MariaDB or PostgreSQL. So these are available too. But not all data is relational. SQL Server is not the only model. There's also table storage. So table storage is one of the oldest features in Azure. It was launched right at the beginning as part of the Azure Storage offering. You get this as part of the storage account that you saw me create earlier. And it's basically each table is a single row-based store where each row can have whatever columns you like in it. And there are some limits on how big the columns are. The data is limited to 64 kilobytes. But the thing about Azure Storage tables is they're very high volume. You can support thousands of requests per second at relatively low cost. So if this simple storage model meets your requirements, it can actually be a very cost-effective way of doing things. But it's very basic as well. So there's no notion of joins. There's very limited indexing. You basically have the indexing that's built in and nothing else. Filtering, if it doesn't fit in with that indexing scheme, gets expensive. So it's a very, very basic service, but it's highly scalable and very cheap. And so that's worth being aware of. Also, be aware that Cosmos DB has added its own table service, which is compatible with the Azure Storage tables, but which does add more comprehensive indexing service as well. So if you want a storage service where you just have tables with columns of fairly simple array of types like strings or numbers or dates, then these table options are worth looking at. And just for completeness, there are some other stores around. Cosmos DB is a thing in its own right. It's fundamentally a document store, so you can put JSON documents in there and it will automatically index them. It has support for doing graph-based work as well if you want to, so you can have connections from documents from one place to another in the store. It's a very different logical model from a relational database. One of the big things about Cosmos DB is that it offers a capacity provisioning approach. So you're able to define the level of workload you want it to support and configure it to give you that, and they will give you guarantees about the response times they can promise given the loads you specified and the amount of capacity you have paid for. They also offer very extensive global replication. So it's a good high volume high availability global solution. Azure also supports Redis Cache. They provide a hosted service for that as well. So that's another model that may be of interest. Another category of storage offering from Azure is message handling. So the Azure storage accounts we've already seen have built-in support for queues. This is very useful for asynchronous message passing. So things like Azure Functions can use this under the covers. It provides you with a way of saying, here is a thing I need to deal with. I'll put that on a queue, and then some piece of compute will pull it off the queue as and when it's ready to handle it. So that is built into Azure Storage Queues, but there are other options. There's Event Hub, which is also the underpinning of the Azure IoT Hub storage. And these have a slightly different model. These are designed for when you expect there to be potentially very high volumes of data coming in. So potentially you've got large numbers of Internet of Things devices all sort of streaming data in, possibly in a very bursty way, and you need to be able to process that in volume, possibly with high parallelization. And so that has a slightly different model for consumption that's more optimized towards that. But it's the same fundamental idea. It's all about decoupling the creation of work and the processing of it. And there's also Azure Service Bus, which is a more sophisticated, slightly more expensive, but more sophisticated offering that also supports some different topologies like pub/sub, as well as simple message passing. And while we're talking about it, there's also Event Grid as well, which is used for distributing events, although it's not really technically storage, it's just it would be incomplete to talk about messaging in Azure without discussing that. And the final set of features I want to look at in Azure is the ones for data processing, so analytics and aggregation and general sort of big data tasks. So distributed query execution is the mainstay of this, where you have a compute farm that is offering maybe tens or hundreds of machines which are able to execute the work underpinning a query in parallel. So the oldest offering for this from Microsoft is HD Insight, which is based on Hadoop, but more people tend to be using Spark these days. So the offerings in that space, well, HD Insight has some stuff there, but there's also Azure Databricks, which is Microsoft's hosted version of the Databricks service, which is basically a fully pre-installed version of Apache Spark that manages all the compute engines for you. But now there's also Azure Synapse, which combines Spark and Databricks and SQL On Demand and SQL Data Warehouse, all under kind of a single grouped set of services with tighter integration. There's also event streaming, which is a subtly different approach to handling things. And again, HD Insight is one way to do this. They have Apache Kafka support, or you can use Azure Stream Analytics, which is another stream-based data processing system. Now, this is slightly outside the realm of storage, but these tend to be used in similar places to the other analytics products, so that's why I'm mentioning them. Also, if you're working in this world, you're often going to want to lift and shift data from one place, possibly transform it and move it into another place. So Azure Dataflow is a system designed specifically for this. Now, if you look at Azure Dataflow and you look at Azure Synapse, you'll see these are two very similar looking products. So it will be unsurprising if those actually merged at some point in the future, because they seem to be based around the same user interface engine. But right now, they're two separate things. There's also Azure Data Lake Analytics. This can be used in this space, although that has kind of been de-emphasized by Microsoft, so I'd be a little bit wary about using that for this particular purpose. Azure Synapse seems to be the way forward for this kind of work. Notebooks are an increasingly important system in data analytics. I've actually got a whole different talk on this, so I'm not going to dwell on these, but there are several different offerings available for working with notebooks in Azure. And just a couple of things to be aware of. Azure Data Explorer provides a way of inspecting your data. Time Series Insights is dedicated specifically to data series where you have sort of a series of points in time and want to visualize changes across time. And then Power BI is a whole world unto itself that I really don't have time to get into at all, but is a very powerful analytics platform. And that completes our whistle-stop tour around the data services offered by Azure. Thank you very much for listening.